all your entire life, when you've been in any type of math situation and you've dealt with an angle, you have only measured that angle in what's called degrees. That's the only thing you're used to. Today, I'm going to show you another way to measure it. All right? Angles can be measured in degrees, or they can be measured in what we are going to start using in this class now, radians. Radians, all right? An angle can be measured in what's called degrees and also today, radians. Lucky for you guys, quick story, we only started using these calculators 2 years ago. So anytime a student needed to convert, let's say 50 degrees into radians, they had to use a formula on their formula sheet until these NumWorks calculators came around, and now they do it for you. All right, so that's what I'm going to show you today is if I'm in degrees, how do I get it into radians using the NumWorks? And if I'm in radians, how do I go back to degrees? Because you have to be able to go back and forth. Have to. All right, so let's start. First up, convert 7 pi over 6 into degrees. Anytime I see the pi, that means I'm in radians. All right, I don't need to say the word radians next to it. You see the pi, I'm in radians. So everyone ready? Everyone locked in, ready to go, because I don't want to have to keep doing this over and over and over again, how to do it on the calc. First thing you need to type in, go to your calculation screen and type in 7 pi over 6, but don't do anything. Just go to your calculation screen and type in 7 pi over 6. Make sure the entire thing is over 6. Now, your calculator has to know you're talking about radians because it just thinks you're talking about some random number, 7 pi over 6. How do you show it's in radians? We need to put radians next to it. How? Go to your toolbox. Scroll all the way down in your toolbox to where you see units and constants. Units and constants. Is everybody there? Okay, that's where we want to go. What are we talking about right now? An angle. So that's where we want to go. Length and angle. And we want to choose angle. Everyone see the first one there? That's the degree symbol. We're going to have to use that in a couple problems. But for now, we want to tell the calculator this is 7 pi over 6 radians. So we scroll down to RAD and put it there. Oh, make sure it's on the out. I didn't do that right. Sorry. Make sure it's on the outside there. Let me do that quick again. All right, so everyone's got 7 pi over 6 radians. All good. All right, we hit enter. Here's what's going to happen. It's just going to give us 7 pi over 6 as a decimal. But what do we want? We want degrees, right? So you highlight it, and then everyone see the 3 dots? Go over to the 3 dots, hit enter, and it'll give you it in degrees. Did anybody's already give you it in degrees? Okay, let me explain why. It's an easy explanation. It all depends on what type of mode you're I bet it says DEG at the top, right? Yeah, so you're always going to get something in degrees, all right? But you can always go to the 3 dots and figure out what it's going to be. Everyone good? So this is equal to 210 degrees. Once you use your calculator, it's an easy conversion instead of going back to the formula sheet, which we had to do a couple of years ago. All right, what do I have next here? All right, you ready to go backwards now for me? Convert 120 degrees into radians. All right, 120 degrees into radians. So go back to your calculation screen. 120, but we need to tell the calculator we're working in degrees now. If the calculator's not going to know that unless we tell it. So you go back to your toolbox, and now you want the degree symbol. You hit enter. And for some of you, if your calculator's already in radian mode, it's going to give you what it is in radians. For you guys that are in degree mode, you got to go to the 3 dots. So it doesn't matter. We're going to have to all go sooner or later. It's just a matter of what mode your calculator's in. So this is 2 pi over 3. So 120 degrees is the same as 2 pi over 3 radians. Any questions yet? Calculator does all the work. All right. Sometimes you won't have pi with it. Okay, that's fine. It'll still tell you it's in radians. All right, so this is 5.8 radians. convert it into degrees, but now we're going to have to round to the nearest degree. And now I'm going to start calling on you. All right, so we got to put 5.8 radians in. So go ahead, go to your calculation screen. 5.8 radians. Sometimes it won't have a pi attached, and that's fine. So 5.8 radians. If you need to turn it into degrees, go to your three buttons, right? The 3 dots to the right. And it should give you your angle, but now you guys just got to round it for me to the nearest degree. What do we got?
How do you put the...
Okay, go back to toolbox. You got to go to units and constants. Keep going down. Yep. We're talking about an angle.
Last time it wasn't there.
And then angle. Yep.
Okay.
All right, so what do we got to the nearest degree now? Start talking with you guys. Kaylee, what do you got? 330. Did you say 2? Yep, good. Everyone else, let me know now. Because if you can't convert, there's no way you're going to be able to do the stuff at the end of class here. All right, how about negative 2.5 radians? Convert that into degrees. Negative 2.5 radians. And then don't try to get ahead of me. What's that to the nearest degree? Nearest degree. Where am I going with that one? Brennan, what'd you get nearest degree?
Negative 143.
Everyone else is good there? Negative 143. Okay, don't go ahead on me here because now we're not converting anymore. Any questions here on how to go from degrees to radians or radians to degrees using your numworks calculator? We're all good. All right, quick question for somebody here. Let me go back to the last 2 days here. I had an angle of negative 410 degrees, right? Negative 410. And I asked you guys, hey, I want the smallest positive angle that's the same as negative 410. What did you guys do? You added what, Henry?
360.
Everyone added 360 to it, right? And then what'd you do here if I gave you an angle of 520 degrees? And I wanted the smallest positive angle that's the same as 520. What'd you guys do? You subtracted 360. Good. Now I'm going to do the same exact thing, but my angle's not going to be in degrees. It's going to be in radians now. So you cannot add and subtract radians and degrees together. All right? It needs to be all radians or all degrees. So what I need you to find out for me before we start this next problem is what is 360 in radians? What is 360? 360 degrees is the same as what in radians? And what do you guys get in here? 360 degrees, Henry, not 360 radians. 360 degrees. What are you guys getting for how many radians that is? You guys getting about 6 and change, right? Everyone's getting about 6.2 on their calculator, yeah? Confirm with me, yeah? 360 degrees is about 6.2 radians. Oh, geez, that's sloppy. That is sloppy on your calculator. You guys want to write out all those every time? No. So let me clean that up for you. You know what number you're staring at right now? That's 6.2 Darn right. That's 2 pi. Okay, nice and clean. That's 2 pi. So anytime we need 360 in radians, we're going to use 2 pi. Okay, we're going to use 2 pi. All right, let's go back. 5 pi over 2. I want a positive and a negative angle that's the same as 5 pi over 2. But I don't want to convert back to degrees, then convert it back. It's going to take too long. So what we're going to do is we're going to take 5 pi over 2. And we already said if you want to go all the way around and get the same angle, you add and subtract 360. We can't do that. You can't add and subtract radians with degrees. So instead of adding 360, we're going to add, what did we say it was equivalent to? 360 is the same as 2 pi. There you go. So everyone on their calculator, 5 pi over 2 plus 2 pi. You don't need to put the radians with it. 5 pi over 2 plus 2 pi. And what's our angle now right there, Henry and radians?
9 pi over
9 pi over 2. All right. We did half the problem. What's the other half, though? I need what type of angle? I need a positive and a negative angle. Yeah. So instead now, what do you suggest I do to 5 pi over 2 now? Subtract, not 360, but what's the equivalent?
2 pi.
2 pi. All right, let's see what happens here. Go ahead, subtract 2 pi. And then maybe you guys got a solution to this problem here. Because something's happening where we can't end this problem here. Shun, what happens when you subtract there? Where am I going? Gabriella, what happens when you subtract? What do you get?
5 pi minus 4 over 2.
4 over... You're doing 5 pi over 2 minus 2 pi? What's your calculator giving you back?
I got pi over 2.
Yeah, so did I. That doesn't answer the question, though, because the final answer has to be what?
Negative.
Negative. So what do you want me to do? Again!
Subtract 2 pi.
Keep subtracting 2 pi till we get the type of answer I need. And then here, I think we'll finally get a negative answer. When you have it, let us know. Shun, Brennan, when you have that answer.
Negative 3 pi over.
Yep. So we cannot add and subtract 360 anymore. I don't know if you want to make a note. 360, same as 2 pi. Okay, so we can't add and subtract radians with degrees. They all have to be the same. All right, anything else before I get into this last part here, which is going to become very easy for you guys now? How about graphing a radian? Graphing a radian. Ready? I'm not even comfortable graphing radians. But you know what I'm comfortable with? Because I taught you how to do it day 1 and day 2. What are you comfortable graphing in? An angle in? Degrees. You know how to put a radian in degrees now, don't you? Yeah. So I don't want you to graph negative 5 pi over 6. Find its equivalent in degrees now. So you go to calculations, negative 5 pi over 6. Tell the calculator you're in radians. And then get the degree measure out. Easy fix. So tell the calculator negative 5 pi over 6 radians. Convert it into degrees, and I think we'll be good. Choom, Henry, what is that in degrees so we can start?
Negative 150.
Okay, negative 150. Fine. So that's what I want you to graph, is negative 150 degrees right now. All right, we got to find out what quadrant we're in, right? Oh, do we really deal with negative angles? No, we only deal with between 0 and 360, so add 360 to it. I think many of you could get away with graphing negative 150 and be fine, because you understand how the quadrants work going the other direction, but just in case. What is that as a positive angle? Gabriella, what is that as a positive angle? Negative 150 plus 360. 210. All right, here you go. Let's graph 210, everybody. Make sure that initial side is on the x-axis like usual. And then what quadrant am I in now? 210. What quadrant am I in? Gia? Third quadrant. Quick, between 180, 270. Where's it closer to? Buck 80. Yep. So make it closer to 180. Where's your arrow going, though? Because remember, we graphed the original angle, which was negative 150. Clockwise. Going clockwise. And does everyone see what I'm asking for? Graph it and then find the reference angle. Okay, some of you guys weren't here on Friday for this. Reference angle is the angle formed by the x-axis and that terminal side. It has, you guys that were here on Friday, what's it have to be? Less than 90 degrees, positive or negative? Reference angles, you guys are here on Friday, are they?
Positive.
Always positive. Always positive and less than 90. So I'm trying to find that angle right there. Let me find somebody who was here on Friday. How do you calculate that reference angle there? Where am I going? Nope. Try that again. Sierra, how do I calculate that reference angle? 210 minus 180. Yep, because remember that was 210. Take away that 180. Yep. So that reference angle is 30 degrees. Positive, less than 90. Oh, whoa. Anybody read the directions? I'm still not done with the problem. Anybody see what that reference angle's got to be in? Radians, yeah. Okay, big deal. Everyone do 30 degrees, put it in radians. And that's what I'm going to ask tomorrow on the pop quiz. Final answer, reference angle in radians. So you can find it in degrees still, but just convert it to radians at the end. And that'll be, try that again. One more time. Candace?
Is it 5 or 6 radians?
Pi over 6. There you go. All right, one more to make sure we're good. 13 pi over 8. Graph it. Find the reference angle in radians. I'll let you guys work on your own. Graph it first. Find the reference angle. Then I need the reference angle in radians. Don't move on to anything else till we go over it. Converted to 292.5 degrees, 292.5. When you go to graph that, that should be in the fourth quadrant, closer to 270 than it is to 360. Rotation arrow starting on the x-axis and going counterclockwise. So there's the graph of it. When you find the reference angle, we should be doing 360 minus 292.5. Again, hey, you guys that weren't here on Friday, when you calculate the reference angle, we never use 270 and 90. Why? Because it's on the y-axis. Reference angle is always x-axis, terminal side. Never the y-axis. So your reference angle should have been, 67.5? 67.5 degrees. How did your calculator turn that into something with pi? 3 pi over 8?
Yep.
Okay, I'm just making sure. I didn't know if it was going to do that for you or leave it as a decimal. So there's your reference angle, 3 pi over 8. I'm going to add one more problem at the bottom, but anything here. Okay, at the bottom here, make a clock for me. I want to challenge you guys now. Make a clock 12 to 12 here. Gia, give me a time. Something oak like 12, 1, 2, not 12, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 o'clock.
2 o'clock.
What do you got?
2 o'clock.
2 o'clock. All right, everyone make 2 o'clock here. 2 o'clock. I want to know in radians, what was that angle that was formed there? Okay, in radians, what was that angle that was formed at 2 o'clock? We don't deal in radians, we deal in degrees, and we can convert. So I want your help first. Can anybody help me find how many degrees that angle forms from 12 to 2 there? How many degrees are in that angle there? Because if you can find me the number of degrees, we can just use the darn calc to figure out how many radians it is. Thoughts? I don't want to give this away here. I want you to come up with a plan. How can I find how many degrees are in those hands at 2 o'clock? What's up, Chris? Got a thought?
Divide 360 by 12.
Why 360?
Because that's the degrees of a circle.
So you go all the way around? You're saying 360, right?
Yeah,
Okay. And then what do you want me to divide it by?
12.
Because there's 12 spaces there all the way around. Is that what you're saying? All right. If I divide by 12, what do you get in there?
30.
Okay, 30 degrees. So what Chris is saying is, hey, every time you go an hour here, you're going 30 degrees. Good job. Good work. So how many degrees total are we going here? 60 degrees. Yep. But I wanted it in radians. What's that angle in radians? So 60.
Pi over 3.
And as you go 60 degrees and you convert it, what's it giving you, Grayson?
Pi over 3.
Pi over 3 radians. Yep. Okay, you should smoke through this delta math right now because it's all on your calculator. All right, converting things over. Go ahead. Let's go. I'm gonna be watching from behind here. Some of us are still having problems getting on task with the delta math, believe it or not. Just getting it wrong on purpose so they can see the final answer. Should be delta math 3.3. And I appreciate if you work right up to the bell.